Hello everyone, so in this video we are going to talk about the UVM sequence class. So let's begin. So I will name the class as sequence 1 because in most of the cases for a UVM based test bench you could just add multiple sequence, and the main aim of the sequence is to just pass the transaction class by randomizing it with some certain conditions, and you could just pass it, and it will pass the transaction class to the sequencer inside the agent, and then sequencer will pass it to the driver, and then driver will drive the very same transaction to the DUT. So there should be a particular synchronization or a handshaking process between the sequencer, and the driver. So both the sequence class and driver class plays an important role for that. So we will find out how does that work. So let's name our class as sequence 1, and then it should extend the UVM sequence. So UVM sequence is the class which is present inside the UVM libraries, and this have this does have a parameter, and that parameter should be the transaction itself and the name you gave to that transaction class. So here you can see we gave it sequence item. Sequence item is the name for our UVM sequence item or the transaction class. So you just have to write it right here. Now we will just end the class, and I will just put a label. So the very first thing I would do is the factory registration. So since UVM sequence is an object, we will write UVM object utils. And then inside it, we will just write the name of the class. Now the next thing I will do is to declare a handle for the transaction class. And let's name the handle to be very simple. Let's name it T, which stands for transaction. Now moving on to the next thing, which is the constructor, and it is mandatory for every class because you have to explicitly call the constructor of the parent, because the parent class in the UVM does have the constructor of the parent class in the UVM does have a formal argument. So you have to call it explicitly. It won't be implicitly called. Otherwise, it will show an error if you don't mention it. So here I should pass an argument as an input. So by default, the direction of the argument is input in system verilog inside function or task. So I will just write string name, and I will name it same as the name of the class itself. Oops, it should be end function. So inside it, I would just call the parents constructor using super method, and I will pass the name as an argument. So the next and the major portion of this class should be the task, the virtual task, which will be called body. And inside this task, all the handshake and communication between the sequencer, and driver occurs. So let's begin. So here inside this, the very first thing we will do is to create an object for the transaction, and you could just do it using the new method, but since you are writing a UVM code, it is better to use the create method, which have lots of benefits, which we will discuss later in our later lectures. So to create an object using the create method, you just have to write the handle equals to, then you have to write the name of the class itself, of which you are creating an object, and the name of the class is sequence item. And then since the functions are not dynamic, you have to access not automatic, you have to access the methods using the scope resolution operator, and the very first thing you will access is the type id method, and then inside it you will access create. And to create, you have to pass a string as an argument, and you could just name it whatever you want. For my case, just to make it simple, I will give it the same name as the handle itself. So I will write T. So now our object for our transaction is created. We will move on with the main stuff, and that is to write the start item and the finish item. So start item and finish item ensures that the communication is being properly done between the sequence and the driver via the sequencer. So to write that, you just have to write start item, and you have to pass the handle of the transaction as an argument, and then you have to write finish item, and you have to pass the same thing as an argument. So between start item and finish item, you will write all the things which you want to do with the transaction. So start item just sends the request to the sequencer, and then the sequencer just forward that request to the driver, and then it waits for the grant. After receiving the grant from the driver, it will execute everything which is mentioned till the finish item. So the main thing we would like to do is to randomize our transaction class, which could be done just by writing T, which is the handle of the transaction class, dot randomize. So this will just randomize the transaction class, and you could just also use with clause to just just to constrain the value of one variable to a certain value. You can do a lots of stuff that you can do with any randomization operation. So let's just stick to the basics, and just to avoid any warnings, because the randomize method does have a return type, so I would just dynamic cast it using void. So this will make it sure that it does not return anything. Instead, it just randomizes the class. So that's done. It will just start item will just wait for the grant, and after receiving the grant, it will just randomize the transaction class, and then finish item kinds of acknowledges that a particular transaction is done. So here, since we are not repeating anything, only one transaction will be done, and which is not ideal for a UVM test bench. There should be multiple transactions since we are doing randomization based verification. So what I will do, I will just write a repeat loop, and I will just put the start item and the finish item inside that repeat loop. So let's go with 10 random transactions. So this will just randomize the transaction class for 10 times, and it will just do 10 random transaction or communications between the sequence and the driver using the sequencer, of course. Now we could just make it more fancy by writing the UVM info. So UVM info is just like the display system task, but it has lots of benefits, and it only works with UVM test bench. So it is more detailed, and it is preferred over any system task when you are working with a UVM based test bench. So to do that, you just have to write tick, then UVM info, and you just don't have to write the semicolon after that. And there has to be 3 arguments inside a UVM info. So the very first argument should be the ID. The ID will get printed in the console. So let's say if we pass SEQ, which stands for sequence, as the ID, so later in the console, something will be printed like this, that this UVM info message has been triggered for the sequence ID. Then the following message will be triggered. So instead of passing a direct string, we could just make it more convenient by calling a method which is known as get underscore type underscore name. So this will just refer to the name of the class, and it will return the name of the class as in string. So in this case, the name of the ID will be sequence1. Then the next argument should be the message we want to print, and this is very similar to the display. You could just print any message you want to print as a string. So for our case, let's just say that the following transaction, oops, that the following transaction the following transaction is being sent to sequencer. So what will happen? The very same message will be printed besides the ID on the console. So when you will run this code, so the same message will be printed with the ID. So the ID will help us to recognize that this UVM info belongs to that particular class, and that message will be printed, which you could write anything. So the third argument should be a concept which is known as verbosity, and I will discuss about verbosity more in details in our later lectures. For this class, let's just say that we are using UVM none. So verbosity is the technique just to filter the info that is being printed by the UVM info. So I'm using UVM none, which has the highest priority, and there are total number of 6 priorities. So besides UVM none, there is UVM low, which has low priority as compared to UVM none. Then there is UVM medium, which has even lower priority, then UVM high, then UVM full, then UVM debug. So the by default UVM none has a value of has a priority value of 0, And by default, if you don't set the verbosity, so you could also set the verbosity. So there's a lot of stuff that I want to discuss that I will do during the next lectures. So you could just set the verbosity, which will work as a filtering method for the UVM info display messages. So you could do it using the console, or you could also write it later in the upper hierarchy of the code or anywhere else. So UVM none uh, has a value of 0, and the default threshold is UVM medium, which has a value of 200. So if you do not mention any verbosity overrides or any sort of filtering mechanism, um, anything which false or which lies, anything which has a value of 200 or less than 200 will get printed. So UVM none will always get printed, no matter uh, what verbosity you set later in the code. So UVM medium has a default priority of 200. So even if I mention this as UVM medium, it will get printed. And between UVM none and UVM medium, UVM low is there, which has a value of 100. And after UVM medium, UVM high is there, which has a value of 300. Then UVM full with a value of 400. Then UVM debug with a value of 500. So like I have mentioned earlier, I will discuss more about this in details in our upcoming lectures. So let's stick to UVM none for this example. So this message will get printed regardless of whatever the verbosity is set. So the next thing I would like to do is to take the benefit of the previous thing we did. So here you can see that in the transaction class, we registered the class using the UVM object utils begin and end. And using this, we could just pass the variables which are mentioned um, inside any class. So these variables are also getting registered, and there's a benefit to that. So using that, I could call lots of methods for those variables. So one of those methods I will use is known as print, and you could just refer to that method just by writing the handle of the transaction class and print. So what this will do, this will print all the variables which are mentioned inside the transaction class in a tabular format. So you could just imagine the format of this code. So first, this message will get printed that the following transaction is being sent to the sequencer, and the values of each of the variables, those are the A and B, which are inputs, and the Y output, they will be printed in a tabular form, making it more readable. So that was the benefit of using UVM utils begin, which I have used during my previous video. So after doing all of this, we are done with the sequence class. And next is going to be the driver class, because you don't have to write the sequencer class because it will be implicitly implemented and there is nothing different besides the constructor. So you could just go ahead and skip the UVM sequencer class and it would just work fine. So for our next class, we will focus on the driver. Thank you.